And let's do it. Okay, so starting on number 14 for the practice final, we need to solve 2 cosine squared x plus sine x minus 2 equals 0. And there's all the multiple choice answers. This is part 1. This is the last question on part 1, which is no calculator. So you'll have no calculator on this question. But part 1 will be no calculator at all. Part 2 will be, use any calculator you want, graphic calculator, regular calculator, whatever. So this is no calculator at all. So go ahead. So solve that. Practice final? Yeah. Well, so there's one under the announcements. Yes, it's just like always, right? I'm working on the one under announcements, but there's actual one in the homework, just like usual. You can print out the one under announcements, just like usual, right? You know what I mean? They're always in 2 places, aren't they? You guys know what I mean? Everybody found that? I wouldn't want you to have not found that at this point. Does everybody know there's one under announcements? So if you go under announcements and click more, under announcements, that's where you find the PDFs. And those you can print out, you can keep them open in a separate window. They're more convenient than the actual questions. Everybody know about that? Grab me if you don't know about that. There's PDFs out there. All right, so how you doing on this question? You got it figured out? This is a really good time to ask yourself an important question. Should I study for the final or just blow it off? Well, how you doing without any studying? Yeah. So I just want to let you know, studying or not studying for a math final is like, and thinking it'll all be okay, is like saying, I think I'll jump off a cliff and somehow I'll just fly to the ground. The laws of gravity will take over and you will lose. So the laws of math classes are hard will take over and you will die academically, right? You'll get a really bad grade. I'm trying to scare you for your good. I'm trying to scare you with truth. To scare somebody with truth is not unkind, no matter what our current popular culture says. To scare somebody with truth, like I said, my children don't play in the freeway, that car will destroy you. That's love, right? So to scare with truth is kindness. I'm trying to scare you with truth. The truth is you must study. Don't even think about working Wednesday night or something like that. You have got to spend hours. I had to too. I had to. And I'm a math person, right? Everybody looks at me and thinks I'm a math person, I guess, or whatever. Probably after all these years. I just walk and talk like a math teacher. But whatever. I had to work hard. I did. Hours and hours. So my point is you got to study for a math final. You got to study for a math final. And you know what? It's going to be so beneficial to you. Even though it's going to be terribly painful. It's beneficial to you. I'm a big believer in finals. So notice everybody has to take the finals. In my class anyway. There's no getting out of the final exam. Even if you have an A, you have to take the final. And the final will count. Everybody knows you can get, like, if you have, it'll replace your lowest score. So there's hope as well. There's both accountability and hope. So if you have on your exams, say you have 89 and a 93, and then you got a 71, because that third exam was killer, right? And then you went back up to 92 and 89. And then on the final, this will be tomorrow's score, maybe. And then in the final, say you get a 91. What's that final going to do? It's going to count as itself, and it's going to come over here and completely replace your lowest score. So it'll count double. Unless it's the lowest, then that wouldn't help you to count it double. I'll just leave it as itself. But it will count as 100 points for sure. For most of you, it'll count as 200 because it'll count as itself, and it'll replace your lowest score completely. So there's a lot. You can really pick up your grade at this point. or you could hurt your grade with a bad score. It is worth 100 points, and it's hard. So I just tried to let you know straight up, most people don't do great on finals. But it's not because I'm making it harder. It's the same old questions. I literally grabbed old exam questions off all the old versions and put them on there. It's the same questions we've been doing all along. It's only a couple from your particular old exams, 2 from each of my old versions. So 2 or 3, so it's just a couple. But it's the same questions, is my point. It's not anything different at all. But it's hard to put it all. Do you remember this right now? No. It's way different than when you had just been doing it all week. You see the difference? That's what you got to bring up to your mind Wednesday night. You got to, and I would say Tuesday as well. What day's Tuesday? Well, yeah, if you can, all you got left, you got much time left. You got to devote yourself to bringing this all up to the top level where it was right when you were about to test on this, because that's what it is on the final. So you can do it, and it's worth a lot of points, and it can help you out. I always learned a lot from math finals. That's why I became a big believer in them. I would always struggle, and then when I studied it again for the final, I hated it. It was a ton of work. But when I studied it again, it sunk a lot deeper second time. It was like, oh, I see what we're doing. So I'm a big believer in it. My daughters at home always think I'm cruel that I don't let anybody out of the final. They say, you don't let anybody out? You're just a mean teacher. Yeah, I'm happy with that. I watch my Rate My Professor. They always kid me about my Rate My Professor. I want to have a good rating, but not too good in the easiness category. Yeah. That's called a teacher who's giving away grades, right? There's some really popular teachers with some really easy marks. I want to be helpful and not have the easiness scale get to. That's what I look for when I'm being faithful. My job is to be faithful to you, to give you real math knowledge and help you all I can to meet that goal. All right, with that in mind, let's do this problem. How do we do these things? Anybody remember anything about this? This is a really hard one. This is from that 3rd chapter. Bernadette, you remember? What do we do?
According to my index card.
Yes.
You can replace cosine square x with 1 minus sine square x.
Excellent. That's what we need to do. Yeah. And if you want to just use your 3x5 cards, you get a full sheet of notes for the final. If you want to just bring your old ones, just put them on there. That's great. That works for me. That's the same thing as a full sheet. If you've already made them and you still got them. Anyway, but make your sheet as you do the practice final, or use your 3x5 cards, your old ones. Yeah, you have to get it all in terms of sine or all in terms of cosine. We can't be having this mix. Remember that? Is that coming back a little bit now? You can't have a mix of sines and cosines. You got to get it to all be the same thing. Well, how can you do that? Well, remember the formula that we had that said sine squared plus cosine squared is 1? Remember that? You could solve that for cosine squared or for sine squared. If you jump the sine squared over there, then clearly cosine squared is 1 minus sine squared. Or vice versa. If you jump the cosine squared, then sine squared is 1 minus cosine squared. Either one, use whichever you need at the moment. So you can replace cosine squared with 1 minus sine squared, because it's equal to 1 minus sine squared. So right there. This will now become, let me get it out of the way actually. It'll now become 2 times 1. I'm just going to use s, if that's okay, just to save some space here. 2 times 1 minus sine squared. And then the other stuff just comes down. So far, so good? You see what I did? I just changed sine to s, just to keep things short and simple. So cosine squared becomes 1 minus sine squared. Why do we do that? Because it's all sine now. You got to get it all in terms of one trig function. You don't want a mix of sine and cosine. We can't do anything with that. All right, so what do we do now? Now we multiply through. 2 minus 2 sine squared plus sine minus 2 equals 0.
You want to get the signs positive, right? So you multiply -1?
What's that?
You want to get the signs positive, or at least that 2 signs?
Yeah, right on, Clarence. You're remembering that. Yeah, it's just a lot easier to make that positive. Well, first off, these guys will cancel, huh? 2 and minus 2, they're just gone. But yeah, what Clarence is saying is a totally good idea. We don't want negative in the front there, because that's just a pain to have the front one be negative. So let's just multiply through by -1, right? That'll take care of that. So multiply by -1, -1, -1. That'll become positive 2 sine squared minus sine equals 0. -1 times 0 is a 0. Right, everybody good to there so far? So everybody see what I'm doing. Okay, so I multiplied through by -1. like Clarence was saying, you want the front term positive. That's a lot easier. Now what? So we got it all down the side. We cleaned it up a little bit. Got it positive in the front. What now?
We're going to fill out, we did in the last chapter, we fill out the, you know, it's, fill out the problem or
Factor out.
factor.
Yeah, you want to factor out exactly. When you look at these two, what do they both have in common? Sine, S. So I'll go back to calling it sine now. Sine of x, right? When they both have a sine, you want to factor it out. Now, well, how do you know what goes inside? Whatever works. Sine times what will go back to 2 sine squared? 2 sine. And sine times what will go back to minus sine? Minus 1. Right, good. Everybody see that? Sine times 2 sine is 2 sine squared. Sine times 1 is sine. Everybody see that?
You split them apart now.
Yeah, because if two things times to be 0, either one could be 0, huh? Remember that logic? If once you've factored it, you've made it 2 things times. 2 things times equals 0, then either one could be 0. Yeah, exactly. So now we say, okay, sine x alone is 0, or 2 sine x minus 1 is 0. I'm going to go to a fresh screen. Everybody good with that? You break them apart, because if 2 things times to be 0, either one could be 0, huh? These are hard. This is one of the hardest things we do. This is from that difficult exam 3, remember? This is why I'm happy to give you a complete replacement, if you know, whatever your lowest score is, because everything's on this final. It's really even-handed. There's all 5 chapters, about 6 problems, about 6 problems or so. 25 questions, I think, on the final. So 5 or 6, about 5. Average of about 5 from each chapter. So it's all on there. If you can do it now, great. You know, I'm just happy if you learn it in the end. It's all good. So I'm going to go to first screen there. So we have sine x is 0. What was the other one? 2 sine x minus 1 is 0. Okay, so let's finish this one up. Move the 1 over. So that'd be 2 sine x is 1. Divide by 2. Sine x is a half. So we got sine x is 0. Sine x is a half. Right now, what do we do now? Unit circle. Exactly. Going to have that unit circle for sure on your full sheet of notes, right? It's been the most important thing in the course, unit circle. So there it is. So I'm looking now on the unit circle. Where is the sign? So remember there's always 2 places? Almost always 2 places. So first off, there'll be 2 places here and 2 places for this one. So 2 places where the sign is 0. Cosine sine. Cosine sine. Sine is 0 at 0 degrees. And cosine sine. Sine is 0 at 180 or pi. I guess we'll say pi in radians. So it's 0 and pi. Does everybody see that? At 0 and pi, the sine is 0. Honey?
I kind of remember like something from the old test, like if the 0, if we got like 2 pi, is that wrong?
Right, yeah, we don't want to say 2 pi. Why not? Look back in the question, or did they even say it?
No.
Yeah, I don't think they even said anything.
Yeah, I mean, we're good now.
So here, yeah, we're good now on this one. So this is going to be 0 and pi.
It'll depend what the multiple choice.
Yeah, if they say you could go from 0 to 2 pi like that, the parenthesis on the 2 means don't give me 2 pi. Right? Parenthesis means you can't touch the number. Do you remember that from bracket? Remember the difference between brackets and parentheses on an interval? Bracket means straight on the 0 up to. So if they say, give me answers, this is what they said on exam 3. They said, make your answers be between 0 and 2 pi, not including 2 pi, not touching 2 pi. Because 2 pi would just be a repetition of 0, wouldn't it? Why would we include that? Make sense? That's what that means? So yeah, so they don't want the 2 pi. So 0 and pi. Now come down here, where's sine a half? Cosine sine, right there, pi over 6. Right here, cosine sine, 5 pi over 6. Pi over 6 and 5 pi over 6. Sine is a half, isn't it? Pi over 6 and 5 pi. There's our 4 answers. 0 pi, pi over 6, 5 pi over 6. Hopefully it's there. 0 pi, pi over 6, 5 pi over 6. B. Is that good? All that without a calculator. Not easy, huh? Won't come to the casual. to those who spend hours investing in it. All right, let's keep moving. Bless you. Let me know if there's a particular one you definitely want to see. I don't want to skip it. Negative 13 pi over 9. They say, all right, take that negative 13 pi over 9 and change it to find a positive angle less than 360 that is coterminal. Coterminal. It's a fancy word. What does that mean?
The same.
Yeah. Co means with. Co-pilot, with. Co means with. Terminate. What's that? End. Same ending. An angle that ends in the same spot. So in other words, a coterminal means ending together. So if you had an angle here, for example, and another one went all the way around and came back to the same spot, they're the same angle, really. If they end in the same spot, they're the same angle. So yeah, it's a fancy way to say same angle. Coterminal, ending in the same spot. So coterminal, same angle, basically. So what's the same as negative 13 pi over 9? Yeah, just start adding 2 pi's. Right? It's always safe to add 2 pi because that's exactly one full rotation. You haven't changed where you're pointing, right? If you add a full 2 pi, since it's negative. So just add 2 pi's until the thing becomes positive. So add 2 pi over 1, top and bottom by 9. That'll be negative 13 pi over 9 plus 18 pi over 9, which is 5 pi over 9. There it is, done. That's got to be the same angle, doesn't it? It's got to be ending in the same place. Because I just added 2 pi. Good so far? Remember number 17? We had a lot of questions on 17. The trail with the lodge and the mountain lake and that. You might remember these. Mm-hmm. So we can do that one again. I don't know if you want to do it again. So we're done. Okay, straight trail with uniform inclination, 16 degrees. Leads from a lodge at elevation of 500 feet to a mountain trail at 9,700 feet. What is the length of the trail to the nearest foot? It's all about the picture. So rather than me, if I just draw the picture, I'll steal your learning. So let me let you draw that picture, and I'll draw it in a minute. So it's all about a right triangle. And this is like the lodge. That's at 500 feet. And this is the mountain, the lake, which is at 9,700 feet. So you got to subtract those, and this side must be 9,200, right, when you subtract? Everybody seeing that? Here's the trail. It's at 16 degrees. It's a right angle. Find the length of the trail. So everybody see how I came up with that picture? So I put the elevation over here on the right side from 500 feet to 9,700. That's a climb of 9,200, isn't it? The difference between those two. Trail goes diagonal up at 16 degrees. So the trail is our x that we're trying to find. So what trig related? Remember SOHCAHTOA. SOHCAHTOA. What trig relationship involves the 16, the 9,200, and the x? Sine. Opposite, hypotenuse, right? This is the opposite side, hypotenuse, adjacent. Right? So that's the sine of 16 degrees is opposite, 9,200, over adjacent x, hypotenuse x. There it is. And what do we do to solve for x there? Cross multiply, right? Put this over 1, diagonal, diagonal. So we get x sine 16 is 1 times 9,200. Get 2 there. X is saying, I want to be alone. That's what x is always saying. It's a real loner. Just divide by sine of 16. Boom. Hit the buttons on the calculator. Make sure you're in degree mode. Yeah, watch your modes on this final. You can be between degree and radian and back and forth. X equals 33377. Hey, there it is. 33,377. Is that good? Feel like you could do a question like that on the final? Questions? Yeah, Bernadette.
On the final, are you expecting us to solve your problems like these a specific way? Because I use the law of sines to solve it.
Oh, yeah. No, anybody's fine with me. I never care. Yeah. Yeah. So with right triangles, you can use SOHCAHTOA if you prefer, but law of sines is always fine. Yeah, law of sines works even when it's not a right triangle. Yeah. But does everybody know, right triangles, you're allowed to use SOHCAHTOA if you want. If it's not a right triangle, you have to use law of sines and cosines. Right? Do it in my head and I can't tell. So try that one. I would start adding 2 pi's again. They're saying find a reference. Same thing. Like try just adding 2 pi. But remember, also have in the back of your mind, this is not quite the same as the other question. The other question just said coterminal, meaning an angle that ends in the same spot. Same angle numbers. This is reference. How's that different? What's a reference angle?
It's not from 0, it's like where it's at.
Yeah. I like the way you said that, Clarence. I think I'm going to start saying it that way. That's a really clear statement. Yeah, it's not from 0, it's from the nearest x-axis. Yeah, reference angle's not from 0, it's from the nearest x-axis. Exactly. That's very precisely stated. That's exactly it. So it might not be from 0, it might be from the other 180 side, huh? It's whichever x-axis it ends up closer to. That's a reference angle. So I would add some 2 pi's here. So 2 pi over 1, multiply top and bottom by 3. So that's going to be, 6 pi over 3 added to, well, here, let me bring it over here. So I've got, what do I got? Minus 13 pi over 3 plus 6 pi over 3, which is minus 7 pi over 3, and then do it again. So now I've got minus 7 pi over 3, add another 2 pi, which is 6 pi over 3. I get minus 1 pi over 3. Can you tell the reference angle right now? Are you picturing where that is? Or is that bugging you? Let's keep going. Maybe I'm confusing you. Maybe you'd rather just keep going until it's positive. That's fine. I'll keep going. So do it one more time. Add another 6 pi over 3. We get, so there it is, finally pi. It's not the answer. I shouldn't circle it. That's not the answer. It's finally become positive, though. You with me? I just kept adding 2 pi, adding 2 pi, adding 2 pi, which is 6 pi over 3. That's a fancy 2 pi, isn't it? Just kept adding 2 pi. Now it's finally positive, but careful. It's a reference angle, like Clarence was saying. It's not necessarily from 0. That's where it is from 0. It's from the nearest x-axis. That's what reference means. Let's go look. You have that unit circle diagram, right? You'll have that on something as you do the thing.
3 degrees.
So let's find that thing. Where is it? There it is. So where's 5 pi over 3?
300.
Oh, there it is. I can't find it.
300.
Oh, I see. Oh, it's right here. Yeah, it's not seeing it. Yeah, 5 pi over 3 is that what it was? 5 pi over 3? Yeah. So it's right here, 5 pi over 3. So from right here, what's the nearest x-axis? Right there, right? This is going to be the reference angle, isn't it? It's going to be the amount from there to there. How much is it from 300 to 360? It's 60 degrees for pi over 3. Everybody see that? The answer is not, again, it's not the 5 pi over 3, because they asked me for reference, which means how far to the nearest x-axis. So adding all those 2 pi's was fine. That's always fine to do. But in the end, you got to give a reference angle. So from 5 pi over 3 to there is 60 degrees, right? 300 to 360, which is pi. Remember, pi is 180. That's 180 over 3. That's 60. Pi over 3. There it is. So that can fool you. Is that good? Because difference between a reference angle and a regular angle. Right? That other problem we did was coterminal. We just, wherever it was. But reference is always to the nearest x-axis. Okay. On we go. Okay, boat leaves the entrance of a harbor, travels 86 miles on a bearing north 58 east. How many miles north, how many miles east from the harbor has the boat traveled? Oh, yeah, it might not be too bad. So draw that. We'll draw that on a paper. North 58 east. North 58 east. So let me draw that. So remember how that works? Here's the axis. North, south, east, and west. So north, there's straight north, but it's not straight north, it's 58 east. So then you go, so there's north, 58 east, you go 58 degrees to the east of north, huh? Is that making sense? Remember how these things work? I probably didn't even go far enough. That looks like more like 45. Whatever. Good enough. Okay. And now what do they want from me? They want to know, well, how far east and how far north and how far east did the boat go? So the boat traveled from here to here. And they're saying how far east and how far north? How far east and how far north did the boat actually go? See that diagram? Right triangle. And how far did it go? It went 86 miles. So that means this is 86, huh? But now we need to find the east and the north. Now, remember how we've learned, haven't we? How do you think about vectors? That's like a vector, isn't it? Vectors, how do you always find the I component, the sideways, the east, the x? X is always cosine, right? Y is always sine. But there's a special caveat to that this time. Is everybody tracking with me here? Remember, whenever we have this is like a vector, isn't it? Just think about vectors. That's a vector. That's a vector. And whenever we have a vector and we want to find the I component and the j component, that's what they're basically asking me. This is like I, this is like j. Call it east, call it north, call it x, call it y, call it I, call it j, whatever. It's all the same thing, isn't it? And how do we always find the I component? It's the magnitude times the cosine of the angle I plus the magnitude times the sine of the angle j, or you could call it r. You know, we've called it many different things in many different sections, but it's all the same thing. Cosine's always for the x, sine's always for the y, right? That's true, but not for that angle. What angle must you have your hands on whenever you do that vector thing? The reference angle, right? See how that reference angle has been huge for us. We got to get this angle. It only works for that angle, not other angles. It'll give you totally wrong answers if you use that thinking with other angles. It's got to be the reference. That's what this question is really testing. So when you do this, this is the right thing to do. But you must use the reference angle, which always means to the x-axis. See, that 58 is to the y-axis. It's just what they happen to give me. That's not the reference angle, is it? That's the one to the y-axis. So I need the other one. Well, you can get the other one. How do we get the other one? You all know what to do now, huh?
Subtracting.
Yeah, just 90 minus 58 is 32 degrees. So 32. So then this is going to be 86. Cosine 32 is going to be the I. And 86 sine 32 is going to be the J. Or, call it east and north, whatever. So 86 cosine 32. I'm getting 72.93 I. And 45.57 J.
You can't just do the sine of 32 and the cosine of 32.
Oh yeah, that's what I did.
Yeah, that's
You got to multiply by 86 though.
I didn't.
Yeah, if you,
Yeah.
if you
Oh,
do
so
sin of 32 equals n over 86, you still have to multiply 86 times sin over 32 and you get 45.6 miles per hour.
Yeah. Well, that's what I get. Yeah, there's other ways to do this. There are other ways. I think this is the easiest though because it's consistent with what we did for vectors. It's consistent with what we did for complex numbers, real and imaginary. See how it's that same thing over and over and over again, but that only works for reference angles. So I really want to drive that point home because the easy mistake to just go, oh yeah, I remember cosine sine, and grab the 58. He's not a reference angle, huh? That's only true. I don't know if you caught that really tightly. This is the kind of thing that happened for me through the pain of studying for a final in math. First time I'd be kind of shaky. I wouldn't get the difference between which angle you grab. And then second time it'd be like, oh. I would have gotten the wrong answer many times in the homework and not been exactly sure why. And then when studying for the final, a lot of times I go, oh, it's got to be the reference angle. I see it now. And I'd have a tighter grip on it. So I'm hoping it happens for you. Looking at it again. So this whole thing we did for vectors and, complex numbers, real and imaginary, X and Y, it's all the same, but it's only for reference angles. So you got to get the reference angle, the one to the x-axis, and then the sideways is always cosine, right? Magnitude times cosine, the up and down is always magnitude times sine. They try to trick you by giving you a non-reference angle. Is that good? Does that make sense on that? So whatever answer that is, how are we doing? We got a little bit of time. 72. What was it? Was it D? D it is. All right, number 22, tangent. We're not going to get to the number 24 she wants to see. Well, oh, did I do it wrong? Oh, they switched the north and east, or I did, or somebody did. Thanks. Did I do that wrong? 45.6 north. Yeah, you're right. Thank you. B. Don't do that. That'd be a bummer, huh? All that good work? It's not funny. Okay. Because I know I've had many students tell me I had that. All right. Tangent of x is 2.0. So number 22. Tangent of x is 2.0. We're not gonna get to 24 today. We'll have to get to it tomorrow. So okay, let's try that. We're supposed to solve that. That's back to solving an equation. Tangent x is 2.0. Let me let you think about it. See what you remember. Good. Definitely. Inverse, huh? Inverse tangent. Absolutely. You got your calculator. This is the part 2. You have your calculator, so pull out your calculator. This is nothing we can do on the unit circle. We got to use your calculator. See the answers? I think it's helpful to see them. Okay, so here's the question. Tangent is 2.0. Use your calculator, so that would remind you. See what I'm saying about the interval up here, guys and gals? See how it's 0 to 2 pi and it doesn't touch the 2 pi? See how they say that? Start at 0, go to 2 pi, but do not touch the 2 pi. It's a parenthesis. So they don't want 2 pi as an answer. You can't go all the way to 2 pi. Anyway, it's not a big deal. So, tangent 2.0. So what do we do? Take your calculator. Tan inverse, both sides, right? Cancels out. X is tan inverse. Oh, what mode should we be in? What kind of answers are these? Radians. So go back to radians real quick. You're going to have to be good at switching modes when you have everything going on a final. So we got 1.107 or 1.11. There's that 1.11 answer. Oh, but they all have that. They all have 1.11. They have a second answer also. That's the real question. How do we get the second answer? Plus pi? How do you know?
Because tangent's positive in the third quadrant.
Tangent is positive in the third quadrant. Why does that matter?
I don't know.
No, you're right, Manveer. You're thinking very well. Exactly. Manveer's got. Remember how whenever we use the unit circle, there's two answers? Right. Let's go back a minute. Where was it? It's been a while, but back here. I think. Yeah. Remember, we got two answers for this one, two answers for that one when we went to the unit circle. So that's typical, right? When we go to the unit circle, and really what we're doing there is we're doing sine inverse, but we're doing it on the unit circle. Right? So whenever you have sine, cosine, tangent, whatever, equals a number, and you go find it, there's two answers, aren't there? Okay? So we should be looking at this and expecting two answers. Back there. There. We should be expecting two answers. So that's one of them. That's one of them. Okay? First, where is that? That's the first quadrant. Well, how do you know? It just looks weird. 1.11. Well, this is 0. This is pi. What is pi? 3.143. About 3. So what's halfway to pi? It's about 1.5. So 1.11 is less than 1.5. It's about right here. 1.11. See how I know about where 1.11 is? You tracking with me? Everybody seeing that? Now, I don't know if that's really important, but where's the other answer? In what quadrant? Like Manveer said, it's in the third. Why? Because all students take calculus. Tangent is, this is a positive, right? 2.0 is positive. Tangent is also positive in the third. That's where your other answer is going to be. Do you remember all this stuff? This was a tricky little thing we did. The other positive answer is in the third quadrant. So we have to find the same answer in the third quadrant. The same answer in the third quadrant. How do we get that? Do we just add pi? Is that right?
Yeah, because you're only going, you add pi from the original, from reference.
Yeah. Remember, you make the reference angle. You want the same reference angle. Remember when reference angles are the same, that's the same angle. What's the reference? Well, that's from here to here is 1.1. That's the angle of the original one. So then in the third quadrant, you want from here to here to be 1.1, don't you? Because that's off the x-axis. So sure enough, it is pi plus the 1.11. So the other one is pi plus 1.11. Use your calculator. 4.25 C. Everybody see how we found that? That's kind of tricky. Same reference angle in the third quadrant. Right? Remember how whenever we find things in the third quadrant, it's 180 or pi plus the angle, plus the reference, huh? It's pi plus 1.11. Is that good? Squeeze in one more. You good to there? So 24, here we go. Wendy's favorite. 24. There's some tricky algebra at the end here. Sine of theta is 1/4. Theta is in quadrant 1. Find cos theta over 2. So first thing is to draw our first quadrant triangle. Try to go kind of quick here. Put it in there. Sine of theta. Remember SOHCAHTOA? Put it up here. SOHCAHTOA. Sine is opposite over hypotenuse. So here's our angle theta. This is opposite, hypotenuse, adjacent. Sine is 1 over 4. Good to there? So how do we find the adjacent side? Pythag, right? A squared plus b squared is c squared. Which side is the c?
The 4.
The hypotenuse, the 4. So the other one's a squared plus 1 squared a squared plus 1 is 16. Subtract 1. A squared is 15. Root it. A is the root of 15. Am I going too quick? You've done that a few times, right? So we've got the right triangle. Right, we just took the sine of theta, opposite over hypotenuse, did the Pythag, got all three sides. Now, what do they want from me? They want cosine of theta over 2. Well, there's a formula for that, which you'll have in your 3x5 card. It's plus or minus the square root of 1 plus the cos of theta over 2. You'll have that on your full sheet of notes, I mean, for the fun. You get a full sheet of notes, not just a 3x5 card, but a full sheet of notes. Or you could just use all your old 3x5 cards. So we do that. Now, is it, what's with this plus or minus thing? Which one is it? Plus or minus?
Plus because it's in the first quadrant.
Plus because it's in the first quadrant, yeah. Right, if theta is in the first quadrant, then half that amount would be about right there. Half the opening of theta, well then theta over 2 has got to be in the first quadrant. It's only half as big as theta. Everybody tracking with me on that? Right? See, this theta over 2 would only be that big, huh? It's only half as big as theta. Right? This is theta over 2. Theta is that whole opening. Theta over 2 is half as big, so it's got to be in the first quadrant. So in the first quadrant, everything's positive, huh? You with me? This is the cosine of theta over 2. So I'm looking at the size of theta over 2. See how I'm doing that? If theta is in the first quadrant, half that amount's got to be in the first quadrant. All right, so theta over 2 is first quadrant, thus it's positive. Okay, so it's positive, or just regular. Don't need anything there. Square root of 1 plus the cosine of theta. What's the cosine? Cosine is adjacent over hypotenuse. Root 15 over 4. All over 2. This is where Wendy was talking about the messy algebra. We good to there? So Wendy, I'm sure, is good with all that. But she wanted us to talk about, what do we do now? Is everybody good to there? So good to there? We got to clean that up. You could. I think it's easiest to multiply by 4 because 4 is the denominator. I'm sorry. I know I've done it different ways at different times, huh? Hope I'm not confusing you by that. I think it's easier to just multiply. I mean, the 2 will work. That's totally fine. If you're good with that, you guys, well, maybe I should do that. Maybe I shouldn't change ways. Just put the 2 under here and under there. That's true. That's good as well. So here, let me bring up to here. I'll do that. This one's going to have some tricks. In fact, let me just go to a fresh screen. So I have the square root of 1 plus, what is it? Root of 15 over 4 all over 2. All over 2. Okay. Yeah. So, yeah, we could totally do that. You could just say, just put that, it's 1/2 and root 15 over 8. Like that. Does that make sense? That 2 just goes under him and hits him. Right? Just becomes the denominator for both. That's correct. That's fine to do. But now I have to combine those, don't I? What will combine those? Top, bottom by 4, yeah. So this will be the root of 4 plus root 15 all over. They have a common denominator of 8 now. So I just put them into one fraction. Good to there? So this is where it gets a little tricky. Because we're not done. We can't stop there. Why not? Well, what does a root over an entire fraction mean? It means the root of the top and the root of the bottom, doesn't it? A root over an entire fraction means a root on the top and a root on the bottom. We agree? Is that good so far? Is that good to there? And, right? Okay, all I did was the root over the whole thing, top and bottom now. Now, root 8, what's that? 2 root 2. Good? We're almost there now. There's a long one. It will end. This problem will end. So now you can't leave a root on the bottom. So what do? You know. Multiply top and bottom by root 2. But are you 100% clear on how that carries out? On the bottom, what do you get on the bottom? 2 root 2 times root 2 is going to be 4. Is everybody okay with that? Right? Because the root 2 makes plane 2 times the other 2 is 4. We good so far? Get to there. Now on the top, what happens? Well, you got to focus on the outer roots and not be thrown off by the inner roots. I know that's confusing. See, this is an outer root, and this is an outer root. So they'll enter together in one big root. So it's 2 times 4 plus root 15. Does that make sense what I did there? And then he'll multiply. Boom. 8 plus 2 root 15 all over 4. There it finally is.
That 2 counts as the outer root. They're going to merge to where that 2 becomes a regular number. However, that the square root sign and the original square root sign outside still stays there.
Yeah, so in other words, it looks fancier than it is. Basically, if you have root of 2 times root of 3, what is that? They go together under one root, huh? If you have 2 roots divided or multiplied, that's exactly what I did here when they were divided. Right? I had the root over the whole fraction, I made it into root top, root bottom. So basically, if you have 2 roots side by side or up and down, they go together under one root. Well, that's all I did here. I had 2 roots side by side. I put them together under one root. Make sense? That's all I did. I said, look, I got this root here, got this root here, put them together under one root. And then I just distributed inside that one root. Hopefully that answer is there. Is it there? Okay, good.